So before we go ahead and jump into the sigma notation and the limit definition of an integral, I want to go ahead and just take a brief review of what we did before. Talking about just doing this in some numbers first. So a is x to 0 going all the way to b, which we're going to go ahead and we're going to call that xn. So we had some interval that we found that we made a rectangle for, right? And then in this case, we're going to use the midpoint because that was the most accurate. So we're going to go ahead and whatever this value inside here is, we're just going to go ahead and call that C of I. So the height of that rectangle, the height is going to be the function, and I plug in C of I. Now, what about the width of that interval? That was delta x, right? Now, before we go through and actually use the summation, there are probably some things with the summation formulas we need to go ahead and do a brief review on. 1. So, if I have the summation going from I is equal to 1 to n of any constant number, that's just going to equal C times n. So what that means is if I have the summation going from I is equal to 1 to 5 of C, that would just equal C plus C plus C plus C plus C, or C times 5. Now, if I have going from I is equal to 1 of n of some constant k, what that means is that is 1 plus 2 plus 3 plus going all the way up to n. And this is the sum of the integers, and that will equal n times n plus 1 over 2. If it was the summation going from I is equal to 1 to n of k squared, that would equal 1 plus 4 plus 3 squared is 9 plus 4 squared is 16. This is all of the, and this is equal to n times n plus 1 times 2n plus 1 all over 6. The reason this is important is because if you were going to go ahead and use the limit definition, you need to be able to solve all of your summation formulas. We're going to go ahead and do this first when n is equal to 50, and then we will go ahead and use the limit when n goes to infinity. So to start off, let's go ahead and go back to what we have here. We know right now that we are looking for the summation when n goes from 1 up to 50. And then what we need here is basically the height and the width of the rectangle. Now, let's go ahead and take a picture of what our graph looks like. Now, I'm using this example for the right hand of the sum, just out of sake of being the easiest value. to pick. So this here, in this case, that would be x1, correct? And then my second rectangle here would be here, if this would be x2. Now that would be if n was equal to 2. But that's not what we want. We want n to equal 50. But the idea behind here is that we are using the endpoints of each of the intervals for x to be the values that we go ahead and plug in to find the height. So the height here of this first red rectangle, that height h is going to be f of x1. And then the second height of that second rectangle, right, that would just be f of x2. So in order to find the generalized idea of the height of this, that's going to be n is equal to 1 of 50 f of x n. Now, I do believe that your book uses I for these. So this would be I going from, instead of n, or x of I. It's the same thing either way. Now, the next thing that we need to do is find the width of that rectangle. That width we find the same way as we did before. That width is just b minus a divided by the number of rectangles we want. In this case, we want 50 rectangles. So that's going to be 2 minus, and I'm sorry, I didn't write down the interval. Let's go ahead and do this on the interval between 0 and 2. So it's 2 minus 0 divided by 50, which all of that, so the widths are all the same, and that is equal to 0.04. Now, how are we going to find out this f of xn? Well, it's at every single endpoint, right? So if my first width is 0.4, that would be f of 0.04. If I want to go ahead and do the next one, this still has a bottom width of a 4. But what is my next value here? Well, it's 0.04 plus another 0.04, or 2 times 0.04. And if I did that one more time, and got one more piece here, that would be another, that would be f of 0.04 times 3. So however many rectangles we're going over, in general, we're going to call that f of 0.04 times n times a width of 0.4. So that's what my summation is, as n goes from 1 to 50 of this function. So let's go ahead and put this in and make all the numbers fit. So my summation goes from n is equal to 1 up to 50. Now I have to plug this into my function, my original function. It's off the screen now, but my f of my function is just x to the third plus 1. So what that gives me here is 0.04. I'm going to go ahead and with this, I'm just pulling this in front right now. So now I have 0.04 n to the third power plus 1. Now we have to simplify this a little bit before we can pull it out. This is n is equal to 1 to 50 of 0.04 times 0.04 to the third times n to the third plus n goes from 1 to 50 of 0.04 times 1. And all I did with that is I took the summation piece that I had of this first part and broke it up times the 0.04 times the second part. Now all of that also simplifies down to 0.04 to the fourth times n to the third plus the summation from n is equal to 1 to 50 of 0.04. So because those are both constants, I can bring both of them out. And this goes now from n is equal to 1 to 50 of n to the third. And this second portion over here, that just because of the fact the summation from n is equal to 1 to n of c is just c times n. This just equals 50 times 0.04. And then the next thing that we need to know is that the summation from k is equal to 1 to n of k to the third power is equal to n squared times n plus 1 squared all over 4. So now I come back in here and replace that. So now I have 0.04 to the fourth times, this is what is becoming 50 squared times 50 plus 1 all over 4. Now I add that to 50 times 0.04 to get a grand total